Hello everybody, welcome back. We are on page 6, which is 4.2, factoring quadratic equations. This is a review of factoring. I remember recall from grade 10 and of 11, of course, we did a lot of factoring. Some of the key ideas regarding factoring, are just we factor a GCF from the expression if possible. Do that right away. That allows you to get your A value as 1 inside if you can. Factor the trinomial if possible, so two numbers multiplied together to give you the C value, added together to give you the B value, of course, and then factor a difference between squares as many times as possible. Sometimes you'll have to do that 1 or 2 times, and of course there's some other ones to look at as well. So without further ado, we'll get into these. They take a little, they take a little bit of effort, but they're not difficult. You just have to look at what you have. The first one is the easiest one. Is one of the first ones you've learned. Remember the A value, that's the coefficient in front of the x squared, is 1. So these are very simple. You can't get a GCF out, so we're at the second bullet. We're just going to factor the trinomial if possible, which of course it is. So we say that it is equal to bracket y minus, my other font here, Times Roman, thank you. So it's going to be y equals y minus 3 y minus 5. So two numbers multiplied together to give you positive 15, added together to give you negative 8. Remember, there aren't very many choices. All you can have is 1, 15, added them together, it'll give you 16. And 3 and 5 is the only other option. So you have two options. If not, then it doesn't factor. Simple as that. So we get y minus 3, bracket y minus 5, right there, first factor. Okay? Next one, we're going to go equals. And here, of course, what you want to do is you want to factor out the GCF. So GCF of 12, 2, and negative 30 is 2. So pull the 2 out at the beginning, and we're left with x squared minus x minus 50, which is very easy to factor in here, because all we need to do is two numbers multiplied together to, oh sorry, I forgot the 6, don't mind me. So now we need two numbers multiplied together to give me 6 times negative 15. Remember the A value multiplied by the C value, which would be 90, and added together to give me negative 1. So it has to be two numbers that are, consecutive, right? So 9 and 10 are the numbers. So we say that's going to equal. So we say it's going to equal. Don't forget the 2 up front. Leave that there, and then it's going to be. So we recopy the 6x squared. Remember, we're doing decomposition at this point. 6x squared, and the numbers have to be negative. So it's negative is going to be a larger number. So it's negative 10x plus 9x. There's your decomposition coming in. That should be familiar. And then we just rewrite the minus 15. All right. Okay. Now we split these. Remember, you guys do hopefully recall. That's going to be equal to, and we kind of split these in half for a minute. We're going to break them down. We factor the GCF out of the first two terms, the GCF out of the second two terms, and what you're going to be left with is one of the factors, and then the two GCFs come together and make the second factor, or the one at the beginning. It doesn't matter how you want to write it. So if I look at the first two terms, they both have 6 and 10. The GCF is 2. They both have an x, so it's going to be 2x. I bring a square bracket in, round bracket. Oh, sorry. And a round bracket. Again, it's up to you. It should give me 3. 3x. And then that's what's left over, the 6x. And what do I multiply 2x by to get negative 10x? It's minus 5. All right, so that 3x minus 5, we need to have that in both. Okay? Or you did something incorrect. So then we factor a GCF out of the third and fourth term, the last two terms. They're 9 and 15, and there's no x there, so it's just going to be 3. 3 is the greatest common factor between 9 and 15. So it's plus 3, and we go bracket, and that leaves you with 3x, because 3 leaves you with 3x, because 3 times 3x gives us the 9x back, and then we have to subtract 5, obviously, again, not just because that's what we need, but because 3 multiplied by negative 5 is negative 15. Square the bracket. So our final step to show this in vector form, I'll recopy this. So remember these GCFs that we factor out, they become the first factor or the second factor. The order doesn't matter, obviously. And then what's left, the common factor, is the second factor. The 3x minus 5. Decomposition. There's the final answer. 2 bracket 2x plus 3, 3x minus 5. You want to verify that, you could remultiply it out, or you could stick it in the graphing calculator and y equals and double check that it works. That's my verification. Just me then. Alright. A little harder, decomposition, but you know how to do it. We've done it in the past. Now the next one is going to be equal to, again, bring out a GCF. GCF is clearly 4 here. Leaving it with 4 equals, I'm going to steal this for a second. It's t, not x, not a big deal. Changing both to t. So if it's 16t, it'll be plus 4t, because 4t times 4 gives us the 16t. And then this obviously would be plus 12. Alright? And that's going to equal, and the 4 is out front, and then this is nice that it has a value of 1. The coefficient in front of the t squared is 1. So these are just simple factors. 2 multiplied together to give me 4. Oh, this should have been minus 10. I do apologize. It should have been subtract 10, or subtract 12. I apologize, because it was 4 times negative 12 gives me the 48 at the top there. Alright. And then it's going to be t plus 6, or t minus 2 at the beginning of what I was initially going to say. It's not going to make a difference. Multiplied by t, subtract 2. So it's 4 bracket t plus 6 bracket t minus 2. Okay? And that's it. That's fully factored. The next example we have is D. And D, you could use decomposition here. There's no GCF you can pull out. Or you can look at the question. Some of you may recognize that it is a perfect square trinomial. I remember in grade 10, so sometimes try to look at that. So when to recognize that is when you have the first term, the x squared term, if that's a perfect square, which it is. We take the square root of 4x squared, we get 2x. And then the c value, the constant, that also has to be a perfect square, which is the square root of 9 is obviously 3. So in order to get the b value, what you need to do is take those two perfect squares that you just found, the 2x and the 3, multiply together of them, and you get 6, and then double it, and it is indeed 12. So this is actually simply 2x plus 3 multiplied by 2x plus 3. And again, you could use decomposition to determine that, but some people will recognize that as a perfect square trinomial, and that's fine as well. And also we can rewrite this, if you wish, as all squared. They're equivalent. So pretty interesting one there. Again, if you don't recognize that, no sweat. You just have to do decomposition like we did in example B, and it'll work the same. Obviously, there's no GCF coming out, but two numbers multiplied together to give us 12. Or sorry, two numbers multiplied together to give us 4 times 9, which is 36, added together to give us 12, is 6. And that is another indication that it is the difference of, it's a perfect square trinomial. So these are perfect squares. So another neat little one. This one here is called the difference of squares, right? So the 25m squared, the square root of that is 5m. And the square root of 36 is 6, and it's joined by a negative, and there's no b value. There's no like bx term. So this is called the difference of squares. So this is just simply 5m minus 6 and 5m plus 6, hence the difference of squares. And again, you can put the plus 6 at the beginning and the minus 6 at the end. It doesn't matter the order in which you represent those. So again, these are called specialty polynomials. Let's do the next one. The next one you're going to notice, it looks right now like it's nothing special here, you know. However, remember the first rule of factoring. Take out a GCF. So if we take a GCF out, they both have an X and they both have a GCF of 2, 50 and 8. So that's going to equal 2x bracket, and what we're left over is 4x squared minus 25y squared. Which is the difference of squares. That's equal to 2x bracket, and remember, 4x squared is 2x, and 25y squared is 25y, or sorry, 5y. So we put the minus 5y at the beginning, or you can put this as plus 5y. It doesn't matter. Just remember the one right second has the opposite sign in between them. Okay? And hopefully you do recall this information here, because it is so important when we're factoring. You have to be able to factor. I told you that in 10. I told you that in Math 11 pre. Factoring is extremely important. It'll continue on with you, you know, in the foreseeable future. Then we got some new ones, factoring. And I'm going to wait until the next video to show you these, just in the interest of time, because it's something new. It's a little new. It's not too bad though. So we'll see you in the next video. Thank you.